Today we are going to prove the quadratic formula and for the standard quadratic equation. And the standard quadratic equation is ax square plus bx plus c equal to 0. And in this equation, a cannot be equal to 0 because a is the coefficient of x square term. And if a is 0, then that term will be 0, and so it won't be a quadratic equation anymore. So this is the standard quadratic equation, ax square plus bx plus c equal to 0, where a cannot be equal to 0. Okay. What are we trying to prove here? We basically are trying to find a formula, a generalized formula, which gives us the solution for this equation. And what do we mean by solution? The solution will be those values of x which satisfy this equation, this quadratic equation. So we are interested in the values of x which satisfy this equation. And the method which we are going to use to find that formula, which we call quadratic formula, is completing the square, because we complete the square formula in that particular method. So first of all, we know that the square formula, either a plus b whole squared formula or a minus b whole squared formula, both of those formulas have three terms: a square, 2ab, and b square term. The formula which has the plus sign has plus sign with its 2ab term, and the formula which has negative sign has negative 2ab term. Here we have plus. We have three terms, all of those terms have plus sign, and specifically this bx term, basically this is our 2ab term basically, because it involves x. So I'll explain that later. So first of all, we know that in the formula of a plus b whole squared, we have a squared. We have a term which is a perfect square, which can be written in the form of a square. So when we look at this particular equation, the first term is ax square. So x square is basically a perfect square. Ax square is not a perfect square, because a can be any number other than 0. So it can be 3, it can be 5. So it can be a number which is not a perfect square. So we'll have to make this first term a perfect square in order to complete that formula. So we don't want this a here. We want to get rid of this a because it is a hindrance in making this term a perfect square. So we'll divide both sides by a, because a cannot be written in the form of a square. And x square is a perfect square, so we want just x square here. So dividing both sides by a, we get ax square plus bx plus c over a equal to 0 over a. So three terms are being added and they are being divided by a same number. So whenever we get such a situation, we basically can separate those terms. So we can write these terms separately divided by this number. This step is basically the opposite of taking the LCM. So ax square over a plus bx over a plus c over a. So a and a cancel out, which we wanted because we want to complete the formula, and the formula has a perfect square term as its first term. So x square is a perfect square. So we get x square from here plus bx over a plus c over a, and on right hand side 0 divided by anything is equal to 0. So x square plus bx over a plus c over a equal to 0. Now we have a first term which can be written in square form. The second term in the formula is basically 2ab, and in this particular case, because we had plus signs, all the signs were plus, and the x term was had plus sign. So we want to complete the formula for a plus b whole squared, and a plus b whole squared is equal to a square plus 2ab plus b squared. So x square is our a square term. Next term will be 2ab, and 2ab term will be this bx over a, because 2ab term has a in it and a is x. So that's why this bx over a, this must be written in the form of 2ab. So when we write this in the form of 2ab, 2 times a is x, so 2 times x, but here we had bx over a. Now we need to write b in such a way, or need to let b in such a way that this term is equal to bx over a. So we must take b as b over 2a, because 2 and 2 cancel out, and we are left with, I'm talking about this particular term, we want this to be equal to bx over a. So, and we also want to write it in the form of 2ab. So 2, because the formula has that term, so 2 into a, which is a is x, so x into b, and b must be supposed as b over 2a, so that this whole term is equal to bx over a. And when we simplify this term, 2 and 2 cancel out, and we are left with bx over a. This term c over a, we need to shift this term to the right hand side. And why do we want to do that? Because we want to complete the formula here on the left side, and the formula has the third term equal to b square, and here b, we have let b as b over 2a. So we want the square of this term on left hand side, and this is very different from that term, so we need to move this term to the right side. So we are moving this term to the right side, so it becomes minus c over a, because on the left hand side it was plus c over a. And we need to complete the formula on the left hand side, so we need to add this b square term on the left hand side, b over 2a whole squared. And this is an equation, we can't just write this b squared term on the left hand side, we need to make this equal. So if we are adding b over 2a whole squared on the left side, we also need to add it on the right hand side. And what happens after that? When we add b over 2a whole squared, we get the expansion for a plus b whole squared on the left hand side, where a is x and b is b over 2a. So we can write this as a plus b whole squared. So a was x and b was b over 2a. So x plus b over 2a whole squared is equal to, when we rearranging the right hand side, we get b over 2a whole squared minus c over a. And we are interested in basically the value of x. So firstly, we'll simplify the right side. B over 2a whole squared will take the square of both the numerator and denominator. We get b square over 4a squared minus c over a. Now we need to take the LCM of these two fractions, and for that we need to make the denominators equal, and we need to make this a 4a squared, and when we do that we also have to multiply this numerator by 4a as well. We are making the denominators equal. So b square over 4a square minus this a, when it is multiplied by 4a, it becomes 4a squared. So we'll multiply both the numerator and denominator because we want to have the net effect equal to 0. If we are multiplying the denominator by 4a, we also need to multiply the numerator by it, so that 4a and 4a cancel out and we are left with c over a. So making the denominator 4a squared, when we take the LCM, we get 4a square as LCM, and in the numerators we just simply write b square minus 4ac. So on the right hand side we have b square minus 4ac over 4a squared, and on the left hand side we have x plus b over 2a whole squared. We are interested in x, so in order for us to find the value of x, we must remove this whole squared, and to remove this whole square we need to take square root on both sides. So taking square root on both sides, square and square root cancel on the left hand side, so we are left with x plus b over 2a is equal to square root of b square minus 4ac over 4a square. Now this numerator is basically, it's not a perfect square. B square minus 4ac, b square is a perfect square but 4ac is not a perfect square, so this will remain under the radical sign. Denominator is indeed a perfect square. 4 is a perfect square and a square is a perfect square. Its square root will be 2a. So we have this x plus b over 2a equal to plus minus square root b square minus 4ac over 2a. And whenever we take the square root of something, we basically put a plus minus sign next to its answer. And why is that? Because let me give you an example. For example, we were taking the square root of 9. So what is the meaning of square root? The meaning of taking a square root of a number is that you are trying to find a number which has, when we take its square, it is equal to 9. So we are trying to find those numbers whose squares are plus 9. So plus 3, when we take the square of plus 3, it is also 9. And when we take the square of minus 3, it is also plus 9. So that's why we put a plus minus sign. So we are interested in the values of x. So we have two cases here. X plus b over 2a, and on the right hand side we can either take plus the answer, or we can take x plus b over 2a is equal to minus times this whole expression. So we are interested in the value of x, so we need to move this term b over 2a on the right hand side. So it becomes square root of b square minus 4ac over 2a minus b over 2a. And when we take the LCM, we simply get minus b plus square root b square minus 4ac over 2a. And on the when we do the same for this equation, we basically get minus b minus square root b square minus 4ac over 2a. So we have two solutions, and there should be two solutions in the case of quadratic, because quadratic equation is an equation of degree 2, so it has two solutions. Under some condition it can have only one solution, but uh, under some condition, a particular condition, but generally it has two solutions. So here we have two values of x is equal to minus b plus minus square root b square minus 4ac over 2a. One is plus case and the other one is negative case. So this is the quadratic formula, and this is a very useful formula because we can find the solution for any quadratic equation using this formula, and we simply need to plug in the values for a, b and c in this formula, and it will give us those two solutions, and in some cases one solution. But every quadratic equation cannot be uh, factorized, or can its middle term cannot be broken. So middle term breaking fails sometimes. So in those situations this formula is really useful.